Yeah, once again, good afternoon, everyone. In continuation of today's morning session, yes, we are going to discuss AR models. So many uh, topics we covered today's morning session. Now we have to cover a complete AR model today's session. We'll go with the syllabus ones. Coming to the first off, already we finished, we know that. Coming to the second, introduction to the database design. Database design and ER diagrams, entities, attributes, and entity sets, relationships, and relationships. So now, additional features of ER model and conceptual design with ER model. Two topics are there. If we know these two topics, we have to apply all, then we will get the database of ER model database for any taken any organization. I will tell you only one database, maybe the college database. I will tell you how to do after completion of these additional features. Then based on that, you complete all your tasks, whatever 16 databases I provided, all your tasks you work out and you design the database and update your observation and record and submit on or before next week. So this is the task I am assigning. Is it okay? Is it clear?
No, sir.
Hello?
Yes, sir.
Is it okay for you?
Yes, sir.
Hello?
Sir, please repeat again.
Yeah. Now, huh? Abhilash, tell me what you are telling. I am not understanding.
Please repeat again, sir. I don't understand about observation record.
Repeat. Okay. Just simple. The thing is, when we are going to design the ER model, here we have to add all the features. Today we learned so many features. What is that? What is entity? What is attribute? What is entity set? What is relationships and its types? And now I am going to discuss about additional features of ER model. Here, all these are the features how to add to ER model. Finally, we have to design the conceptual design with ER model. So when we are going to design the model, ER model, here we have to include all these features of ER model. That is called as conceptual design of with ER model. Means your first experiment in the laboratory is conceptual design with ER model. Now I will explain one data set, one database, college database. I will explain in the today's lecture. Based on that, how to add all these features, I will explain. So based on that, you only design your 16 databases, whatever I given to you. The same thing, you update your record, update your observation after that record. So this is very important thing. That's why please attend carefully and respond whatever I'm going to ask. Clear? Now clear?
Yes, sir.
Yeah. Abhilash, is it fine? You only question. That's why I'm asking again.
Yes, sir.
Abhilash is not responding. Yeah. Yeah. Now, as per the syllabus, he given database design and ER diagrams. Here, as per the syllabus, if you observe, here, database design and ER diagrams. Here, how to design database design with ER diagram. There are only 6 steps are there, very simple steps. Okay, very simple steps. Everyone they can understand. Already I mentioned many times how to design a database. So that is very very important. If you know that, then only we can do that. Already you people are done because you are already identified attributes, entities, and relationships and types of attributes. Already you are aware. Even though I'm again as per the syllabus, I am giving the information. The database design. Yeah, requirement first one. First phase is requirement analysis. Yes. So whenever someone will ask to design a database, first of all we have to select the requirement and analyze the requirement. So what are the? For example, I want to construct the database for the college. Now I'm going to collect the requirements first. Then after collecting, I have to analyze. Then what are the entities I have to identify? Faculty, students, canteen, classroom, library, sports, maybe the bus, maybe the administrative office and examination branch and the departments and labs. Like that, these are the entities I have identified. And along with that entities, I'm going to identify attributes of those entities and association. So one entity is connected to other entity. Faculty, teachers, students. Faculty visits to the library. Students visit to the library. Faculty visits to the canteen. Even students also visit in the canteen. So everyone, every entity is associated. So how it is going to connect, we have to organize. So that is the analysis we have to do. So that is what requirements analysis. Anything is missing, then you need to add. That is what the requirements analysis. Here the first phase already you people are doing that. Here, when you want to design the database, you must be do the following process. First one is the requirement analysis. Clear? Okay. All of you clear this? First phase. Please respond so that I can design the AR model on sample today.
Yes, sir.
Okay. Coming to the second phase, conceptual design of AR model. Now, what is the meaning of conceptual design of AR model? Is a today's discussion. Means you have to design the complete AR model using the all features. The conceptual means graphical representation. Here only the analysis. Here conceptual design of database means here all ER diagram properties we need to use and design the model. So that is a ER model that is called as conceptual design database. Now coming to the third phase. The third phase is your logical database design. Nothing but your second experiment. That is a relational model. Logical database. A relational model means tables. You have to convert this conceptual model to relational model. Means how to convert. Here we will discuss in the next unit this how to convert and how to implement the logical database. How to design we will learn in the second unit. The second unit is introduction to relational model, entity concept. Introduction to relation. We have to consult the relation. That is called as logical model, logical database. The logical database is like a relations. Means all tables we have to construct using SQL. Already I told you very clearly. Structural query language we use and we can develop the logical database. Now after this, the fourth phase is schema refinement. So what is the meaning of schema refinement? So after construction of the relation model, sometimes that is not going to satisfy all the problems. So that we need a normal forms. So we have a normal form. We are going to apply normal forms on the relations. That means it is going to change your relations. Sometimes these relations are going to divide into some more sub-relations as per the normal form. I told you normal forms are very important because of the normal forms only database management system is working. So that we can learn in the third unit normal form. How we have five normal forms. Here how to apply and when to apply. After applying, what the results will get. All these things we will discuss. So there is a normalization or schema requirement, changing of the schema, changing of the relation. Now, the fifth one, that after normal forms are satisfied of your database, now physical database. Now physically we have to store. You know physical storage. So we have to store these things into physical storage. Now the last one is the very important sixth one. So after storing the physical storage, then we have to access with the help of some application, maybe the Java application, .NET application, whatever the application we can do, to use it and we can access from the physical storage. This is the final storage. So we can learn this application and security design from your Java and other programming process. So up to this only we can do in our database management system. Fifth phase. The sixth phase is, the external event, maybe the Java or content applications. People, they are going to develop their application and they are going to access the data from the physical database. So this is what exactly the six steps are going to involve when we are going to design the database with ER diagrams. Now clear everyone, these six phases? Hello? So all six pages we have the experiment. This is this requirement analysis and concept design is first experiment. Logical database design is second experiment. The schema refinement means normalization, third experiment, and physical database design is fourth experiment. These applications are not there. If you like that, we can learn all the phases also except this sixth phase. Is it clear? Is it clear?
Yes, sir.
Hello?
Yes, sir.
Hello? Hello? Is it clear, everyone? Please don't waste the time. Today I'm going to finish the conceptual design of your model. Is it clear?
Yes, sir.
Yes, sir. Yes, sir.
Now, yeah, we are coming to as per syllabus. Coming to next topic is what? Entities, attributes, entities, based, all these things. So that already we discussed. Yeah, already we have discussed what is entity. Okay, already we know attributes. What is the attribute? Types of attributes. Simple attribute, composite attribute, single value attribute, multi value attribute. Okay, partial key attribute, stored attribute, null value attribute, derived attribute, key attribute, attribute values, values domains, descriptive attribute. I think I have not discussed about descriptive attribute. Correct? No. I think the descriptive attribute we have not discussed in the earlier. Correct?
Yes, sir.
Hello? Yeah. Descript, what is the meaning of descriptive attribute? Here, this attribute is going, this attribute, the attribute which is having a relationship, that is called descriptive attribute. For example, I will draw one ER diagram. Employee is in works for company. Works for company. Now, till now, we know only uh, remaining attribute, employee ID. Please note it down. Employee name and employee salary, employee designation, and the phone number, and etc. etc. Now coming to the company, company ID, company name, products, or etc. etc. So now, here are so many different categories attributes you can have for the entities, but the descriptive attribute is for only relation. So how to write this descriptive attribute? Just you have to connect with relationship. So what is the employees works in company? Employees works in company. One employee works since. If I write since is an attribute for the works for. Since means from when he is working. So such type of attributes are possible for relationship sets. Yes, those attributes are called as descriptive attribute. This is descriptive. The attribute which is for relationship set, that is called as descriptive attribute. Clear? Hello? This is a special attribute. Very important also. So many cases we are going to use. Everyone is clear about this descriptive attribute.
Yes, sir.
Hello? Why? What happened after lunch? You people are sleeping. Descriptive attribute is clear.
Yes, sir.
Yeah. Now, you know relationships and relationship sets. Sure, what is the relationship? What is the relationship? And Hello, is this audible? Hello?
Yes, sir.
Yeah, sorry for the inconvenience. In our campus, power gone. Just I joined through my mobile net. Please try to respond quickly because I think the mobile how much data is available. I don't know. Please try to understand. Please respond quickly. Right. Now we know already relationships and relationship sets, types of relationships: unary, primary, ternary, and quaternary. Correct? Yes or no?
Yes, sir.
Hello. Yeah. Now coming to the mapping cardinality. Yes, we know the mapping cardinality. What are the mapping cardinalities are there? Tell me quickly. What are the mapping cardinalities? Hello.
One to one, one to many to one, many to many.
Yes, very good. Four mapping coordinates are there. We have discussed already with example. All these properties we have to add. Right. Now coming to the additional features here as per the syllabus. Now here this additional features of ER model we are going to discuss. After this, we'll go with the designing of conceptual design with ER model. Means we have to add all the features that is called as conceptual design. I will show you one sample. You work out all 60 samples. Before that, we'll go with the additional features of ER model. The first one is the key constants. Here, what are the key constants? Super key, super key, candidate key, primary key, foreign key, and unique key. These are the five key constants already we discussed. Correct? Yes or no?
Yes, yes, sir.
Yeah. The
Discuss.
next two, the next additional feature is participation constraint. Already today morning we discussed about participation constraint. What is the total participation and partial participation? Means all the entities of that particular entity set is going to involve, there is a total participation. Only some of the entities are going to participate to relationship, that is a partial participation. The partial participation representation is single link. Total participation representation link is double link. Clear? Already we discussed in today's morning class. Clear? Hello? Is it clear about part?
Yes, sir.
Yeah. Now weak entities. Already today morning we discussed about weak entities and strong entities. Always the weak entities are going to depending on another entity, but the strong entity never depending on any entity. It is having its individual rules. Already we know very clearly. We discussed about that particular customers borrows loan. That is also we can have weak entities. That is loan is a weak entity. Why loan always depending on the borrowers, but customer never. All customers are not a borrowers. That is what weak and strong entities. Strong entity representation is rectangle. Weak entity representation is double rectangle. Clear? Today morning we discussed about this. Clear? Clear?
Yes, sir.
The fourth one is we are not discussing. We are going to discuss now class hierarchy. Very simple way we can represent class hierarchy. Very simple. Don't get any confusion. You know all the class object oriented programming. You know the inheritance mechanism. What is the meaning of inheritance? Can you tell any one of you? Same thing will be work here. What is inheritance? Hello? What is a inheritance?
The process of acquiring properties from one class to another class.
Yeah, very good. What is the advantage of inheritance? Can you tell?
Reusability.
Yeah, reusability. We can define one time, you can use many times. The same way, the class hierarchies in your ER model also, it is a reusability concept. The simple mechanism is here we have to classify the particular entity into different categories. For example, your employee this is a class hierarchy. This is a class hierarchy representation. Triangle is the class hierarchy representation. Some books are going to refer reverse triangle also. Both are same. Like this also they can mention. Okay, we can like that. Now employee. Here hourly employee also employee, contract employee also employee. But hourly employee having different attributes, contract employee is having different attributes. If you don't classify these two, directly if you can use employee, it is all attributes you can manage for employee. But when you are going to classify, your employee is having employee number, employee name, employee salary, and hourly employee is having hourly wages, hourly works. Along with that, its superclass attributes also. Why? Here, every employee is having employee number, employee name, employee salary. The same way, contract employee also having its own attribute. Along with that, its parent class attributes. So that's why we are reusing the attributes. Clear? So this is what exactly the class hierarchy. You can define class hierarchies also in the AR model. Now understood this? Hello? If you understood this class hierarchy, next following two topics also very easy. That's why. Hello? Have you understood this concept?
Yes, sir.
Yes, sir.
Yeah. Here means here base is employee base class, derivative class are hourly employee and contract employee. Means base entity is employee and derived entities are hourly employees, contract employees, or full-time employees. You can derive many number of entities, but here this base entity attributes you can share to hourly employee and its derived employees, means the contract employees, along with its own property. So this is very important. But this employee entity cannot share the properties of its derived entities. You know the hierarchy inheritance mechanism in the object-oriented programming. Same concept is achieved here. Okay, always the derivative class only use the properties of its base class. Same here also same. Here, the base class never extend the properties of its derivative class. Understand now? Understand now? Hello.
Yes, sir.
In the same way, I can design one more sample here. I can write here staff is a class hierarchy. Remember always, class staff is a maybe the faculty, maybe the non-teaching, maybe the administrative, like that. Everyone in the college. Yes, but every staff is having one ID. It is a generalized attribute. Here, every staff is having a name. Generalized attribute. Every staff is having salary. Like that, some generalized attributes are there in the parent entity. Now, specialized attributes at the its derived entity. Here, specialization, generalization concept also there. Next to following slide. That's why I am telling. Sir, when we are going to use class hierarchy, we know the specialization, generalization. Specialization means specifically those attributes are related to that entity. Generalization means those attributes are applicable to its derived entities also. Now understand? Everyone has understood class hierarchies, how to design. Hello. Whenever it requires, you can add in your ER diagram. That is what I am telling. Are you clear about this? One more sample
Yes,
also I
sir.
given. Yeah, please try to make it out in the class hierarchies is possible in your database design. Then you can use this class hierarchies. Then we can tell there is a conceptual ER diagram. Please. Now, for this extended ER model, already I told you specialization and generalization. Just now I given the information. Specialization is nothing but here top to bottom. When we are moving from top to bottom in your ER diagram, in a class hierarchy, that is specialization. Here generalization is nothing but bottom to top. When we are moving derived entities to base entity, moving from the derived entity to base entity, that is called as generalization. Nothing but very simple example here I would run. The person is a common generalized entity. Okay. Now name, street, city, these are the common attributes of every person. The person is an employee or customer, or you can take another thing. Okay. The employee, customer, maybe the businessman or something. You can classify the person. Here, but this employee is having name, street, city. That means these attributes are shared to its derived attributes directly, along with derived entity attributes. The salary and customer is and customer like that. Again, this employee also again he will classify it different officer or teller security. Here like that, here we can derive from top to top. When we are moving specifically, that is called specialization. When you are moving generalizedly, that is a generalization. Specialization, generalization. Specialization and generalization under the part of class hierarchy. Now clear everyone? All of you clear this? Hello? All of you clear this generalization and specialization?
Yes, sir, clear.
Yeah, very simple. If you know the inheritance, that is very easy. Now, the final one is for this AR model, I am going to finish up this aggregation. So, this is one important topic. Sometimes people will ask, maybe the training place, maybe the examinations are everywhere. This is very important topic. Sometimes it will going to confuse you. Aggregation. Very simple. When I am preparing AR diagram, when I am preparing AR diagram, sometimes the AR diagrams are scaled like this. Why? Because the employee works on branch, employee manages manager, employee manages branch, job manages manager, and sure, what happened in this process? Here we got one link from relationship to relationship. So as per the AR diagram rules, there is no chance of association between relationship set to relationship set. So this is the problem. Here we have the relationship between entity to its attributes, entity to its relationship set to entity, but there is no chance of the relationship between relationship to relationship. But in the process, when we are doing, sometimes the chances came job managers manager, but instead of this, it has came. Now to avoid this situation with the help of aggregation. Now understood problem? You understood everyone? First of all, understand the problem. Your diagram with redundant relation. Exactly, because the redundant relation. Job works on manager, job manages on manager. Here, redundancy. That is what? Because of this problem. Redundancy of association is there. Understand the problem? But solution is right, but this is not possible in the ER diagram. This is the solution for given case, but this presentation is not possible in the ER diagram. Now clear? Everyone has understood the problem? Hello? All of you understood this problem or not? If not, I will explain again, but respond.
Sir, once explain again, sir.
Sir, your voice is not clear, sir.
Oh, what I now clear? Now my voice is clear now? Hello?
No,
No,
sir.
sir.
What is going on? What about now?
Yes, sir. Now,
Is it clear now?
yes, sir.
Yeah. Okay, okay. Sir, now, sir, just when we are going to observe, because of the given case study, I designed ER model like this. Employee works on branch. Okay. Employee works on manager. Job works on manager. Job manages manager. Job manages manager. Again, branch manages manager. So what happened? Here, redundant relationships are there. That means how it is right actually. The ER model is right, but in a ER model, there is no chance of association between one relationship to another relationship set. But because of the case study, here we have designed like this. But ER model is not going to accept your relationship between one relationship set to another relationship set. Now understand the problem? Have you understood this problem?
Yes, sir.
Yeah. Now to avoid this problem from ER model, there is a mechanism that is a aggregation. So what is the meaning of aggregation? I will tell you. Like inheritance mechanism only. Here we have to define total complete this this conceptual design this ER model into one entity and connect with manager. Now what happened? Employee works on branch, job works on branch. Now employee manages manager, job manages manager, branch manages manager. Now like this. That means we have to aggregate this. This is aggregation. What happened here? The problem is there is a chance of association between entity relationship set to relationship. Here there is no chance of relationship set to relationship. Here what happened? This is one entity, aggregated entity. This is another normal entity. Now we are provide a relationship between one entity to another entity. Then ER model is going to accept. So now we have to make it aggregation of one set of relations into one entity. Then we can connect to another entity with the help of one relationship set. Now the solution is same here and here, same solution for the same problem. But the problem is here the ER diagrams never accept the link between entity set to relationship set to relationship set. So that we have aggregated the things into one entity and we have to implement remaining things as it is. Here this is what aggregation. Now understand? All of you understood everyone? All of you understood this?
Yes, sir.
Very simple actually. Don't confuse. Simple. Just I am going to take as one into one entity. I am going to combine all this. It is going to cover as a one entity, one entity. So inside relationships is there, but you have to make it outside as an aggregation. Now clear? Clear?
Yes, sir.
Now the last topic and your experiment. What is that conceptual design with AR model? Now I am going to show one AR model. Based on that, you design AR model of your 60 data sets. Now tell me which model I want to design. You must respond now. Everyone must be responsive. Then I can do that. Can I design college AR model now? I'm going to take only 4 to 5 entities and only less attributes you can add, okay, in your database. Shall we? Hello? Shall I go with college database to designing of conceptual design of ER model? Hello?
Yes, sir.
Yes, sir.
Yeah, please. Now, now first one I am going to take faculty. Now you tell me one by one, please. Faculty, teachers too. What are the entities? Can you tell me? Faculty and
Students,
students. Next,
Library.
next tell me, students. Library. So now, library is common for faculty and students, right? Both the people can visit. Yes or no?
Yes,
Yes
sir.
or no? Yeah. So that faculty and students, I can make it one association first. Faculty, this is your perspective. Don't think always it is same for all. Maybe the person to person, their perspective will be different. Already I told you. Are you clear? Faculty ID is the attribute. So this is a which type of attribute? Faculty ID is which type of attribute?
Key
Tell me.
attribute. Key attribute.
That's why we have to show that attribute. Already I told you many times. Student all ticket is what? All ticket number is which type of attribute?
Key attribute.
Key attribute.
Key attribute. Now coming to the faculty name, F name. Here, faculty name is which type of attribute? I am taking F name. Which type of attribute it is?
Opposite attribute.
Which type of attribute? Huh? Which type of attribute? Hello? Name. Faculty name is which type of attribute?
Multi-value.
Hello? Huh?
Composite attribute.
Composite attribute, very good. Someone is telling multivariate attribute. No. Faculty name. Many names are there for one faculty. It is a composite attribute. What is that? First
First.
name, middle name, and last name. Like that, the student name also a composite attribute. Yes or no? Like that, we have to draw. We have to include all the attributes. What I am writing, you understood now. Now, correct? Are you clear?
Yes, sir.
Yeah, like that we need to design the model. Okay, faculty, teachers, students. Now, when I am going to associate the faculty, teachers, students, one attribute must be the common, so that we can associate. So that's why here, what is the common attribute in the both? Maybe the department. Correct? Hello, is it right or wrong?
Yes, sir.
Department. So next, what are the attributes? Yeah, we'll add. Depending on the situation, we will add one by one. Okay. We can add different categories of attribute. You know, date of birth, age, section, year, date of birth. If I take date of birth and age, so now you know date of birth is a stored attribute and age is a
Derived attribute.
derived attribute. That must be represented in a dotted oval. Like that, we need to write all the attribute categories. Right. Next, one more entity, library, right? You told us library, correct? Okay. Library. Here, when I am going to connect the library to the faculty and the library, but faculty not teachers to library. That's why the faculty visits library. In the same way, students also visits library. Yes or no? Here, you draw properly. Just here, the graphical representation is not perfectly possible to draw here on board. It is good. So both are going to visit library or not? Faculty as well as students. Yes or no? Like this, you must try. Hello? Are you clear? Are you clear this?
Yes, sir.
Now, faculty visits library, students visit library. When they will visit, here again, one common attribute same means that must be a CMR college. Now, the college is a college name. Your college name. Here also college name. Here also college name. So that we can win. Are you clear? What I am writing understood now? library name, location, head of the library, number of books, all these things. Are you clear now? Understood? Hello? When we are associating faculty to library, we need one common. When we are going to have association between one and students to library, we need one common attribute. Understand this? Hello? Hello? Is it audible? Dear students, is it audible?
Yes, sir. Audible.
Now, is this clear? Is this clear? Is this
Yes, sir.
clear?
Yes.
Tell me one more entity. Faculty, students, level is over. One more entity. Tell me.
Exam, sir.
Exam branch. Okay. The exam branch. Here, there is no relationship between library to the examination branch. There is a relationship between faculty as well as students. Yes or no? Yes or no? But different relationship. The faculty evaluation of papers to the exam branch. Students writing exams to the exam branch. Yes or no? Are you clear? You
Yes.
please arrange proper way. I am not properly designing because of the online mode. It is not properly I am arranging, but you arrange. The faculty maybe the evaluating papers from the examination branch. Students are performing their exams from the examination branch. Correct? Are you clear? Now exam branch is having attributes. What is that? Location, and the college also important because the college name. The student and faculty is having same college. Hello, can anyone tell other entity to add here? Is it audible? My voice is audible. Time is 2:50. Is this my voice is audible?
Yes.
Now course. The course. The course maybe the faculty student. Here, here please arrange in a proper way. Here please don't mind. The course. Now we have added course here. The faculty teaches course. The course is having course ID, course name, and department. Because of the department, it will be matched. Now, students enrolled course. Now, this relationship also having with examination branch. Examination branch provides courses. Our examination branch conducted exams for courses. So like that, now here college name and college name must be a common so that we can have the association. So like this, we can connect. Now we have to define all the attributes. Now along with that, we have to define the cardinality, total partial participation, and weak and strong entity. Let us check that. Now faculty teaches students. Faculty teaches students. Here, how many faculty teaches students? One faculty teaches many students. Yes or no? Yes or no? Hello? So I'm applying cardinality
Yes,
now.
sir.
Some faculty teaches students. Yes or no? That's why one to many. Hello? I'm using numbers one to many. Are you following? Hello? Hello? Is this my voice is audible or not?
Audible,
Yes,
sir.
sir.
Are you following?
Yes,
Are
sir.
you following? Yeah, please respond. Now faculty visits library. Now tell me, faculty visits library. What is the cardinality? Faculty visits library. What is the cardinality? What you people you are doing? Respond quickly. Time is running. What is the cardinality for faculty visits library?
1 to 1.
1 to 1. One faculty visits library, one. Many faculty
Many
visits
to
library
one.
to one library, many to one. Students visit library again, many to one. Faculty evaluate papers to examination branch. What is the cardinality? N to 1. Yes or no? Hello? Hello?
Yes, sir.
Very simple. Why you people are not responding, I don't know. The students performing their exams from examination branch. Again, N to 1. The faculty teaches course. There N to many. Many faculty can teach many courses. So like that, we have to apply the cardinality. Then weak and strong entities. The faculty teaches students. Here, which is the strong entity, which is the weak entity? Students are depending on faculty. Yes or no? But faculty never depending on students. Yes or no?
Yes, sir.
So that this is a students is a weak entity in this case. Please. Now coming to the students visits library. Here we cannot do anything here because don't expect always we can get a weak and strong entity. Sometimes we cannot get. Sometimes all the entities are strong. Sometimes don't worry about it. Faculty visits library. Even library also not depending on faculty. Uh, Now faculty evaluate papers on exams. Again, the exam branch is depending on faculty 100%, so that it is a weak entity. Understand? Hello? Are you following?
Yes, sir.
Yeah. So like that, we have to define weak and strong entities and total and partial participation. Sir, what is the total? What is the partial participation? Sir, total means all the entities are going to participate in that entity set. That is the total participation. Sir, faculty teaches students. The faculty teaches students. The students, total students are going to participate. Here, if you do like that, this is a total part, single line. If it is a partial, then two lines we have to write. But here, faculty is a total participants, but students never attend all the students. That's why students are partially attend. Means they never attend all the students because today, how many students are there in the class? 60. But out of 68, only 68 are attend. That's why this is a partial participation. Are you clear? Are you clear? Hello? Hello?
Yes, sir. Clear, sir.
Now, students writing exams. The students writing exams. They are not all the students are going to write the exams. That's why this side, students side, it is a partial participation. Exam side, it is a full participation, total participation. Coming to the faculty, visit the library. I don't think so. All the faculty is going to utilize it. That's why it is a partial participation. Students also partial participation. The faculty teaches course. Here, not all the faculty teaches all the course, so that it is a partial participation. Like that, we can define types of entities, types of relationships, cardinalities, types of attributes, and add the cardinalities and weak entity, strong entity, and total and partial participation. That is called as conceptual design of your model. Now, everyone, please practice your conceptual design AR model one by one like this. All are must be in a neat way. Use pen and pencil and your observation. Already I told you with pencil only you do it because sometimes some adjustments are required. In that way, you have to mention. So that is what exactly the conceptual design of VR model. Now understood everyone how to add all the properties of ER model now? All of you understood this?
Yes, sir. Understood.
Can you do that by before next week for all of you must complete that 16 experiment like this? Hello?
Yes, sir. We'll do it, sir.
I will show you one sample, otherwise I will show you uh, one sample reservation, airline reservation I will show you. Already I drawn that. Just opening. Please observe that, then you can understand how I implemented that. Airline reservation. 1 minute. Just it is sharing my screen. Is it visible now? Hello? Is it visible?
Yes, sir.
This is I've done airline reservation. How it is done? Simple. Here, airport. So these are the attributes. Now, airport is associated with the flight log, and airport associated with the arrival airport to flight log. The airport can land airplane type. So like that. Here we have taken all and we are implemented. Here this is a weak entity in this case. So like that, your cardinalities, types of attributes, all we have to include so that we can get one complete database. Like this, we have to design for all. So don't think for every data set like this only. So everyone don't copy same like this. So you analyze means as per the requirements, we have different entities, we have different attributes. Here, as per my analysis, I have taken these are the attributes and these are the entities and relationships. But your analysis is different, so that we can do your own way. But the model is like this. Okay, you have to do like this. Understand now? Understand? All of you understood this?
Yes, sir.
Hello? Yeah. If possible, I will share this also. Don't worry. Huh? Okay.